Hi everybody, I'm Greg Fishel. Welcome to the Friday bonus weather video number 3 for this week. And I thought we'd have some fun with the old concepts of lightning and thunder. And over the years, just casually talking to people, I've heard all sorts of different ideas about how do you calculate how far the lightning is away by counting the time between you see lightning and hear thunder. And those formulas have varied quite a bit. And so I thought today I would clear up any confusion and show you the science behind those formulas and what numbers they produce for us. So hopefully this will be an enlightening experience. Now that wasn't exactly a stroke of genius, was it? Okay, let's move on ahead here. And we're going to take a look at the speed of light versus the speed of sound. First of all, well, the speed of light is 299,792,458 meters per second. It's trucking, okay? Now, the speed of sound, by comparison, is 343.1 meters per second, so a good bit slower. How much faster is the speed of light than the speed of sound? 873,775.75 times as fast, okay? But wait, the speed of sound actually depends on the temperature. It varies from cold to hot. So let's take a look at a little table here that shows that. Over on the far left column, you have the temperature in Celsius, and next to it, the temperature in Fahrenheit, the Fahrenheit equivalent. And by the way, might as well take this opportunity. This is a personal method that I came up with a long time ago to help me quickly convert from Celsius to Fahrenheit or backwards. So if you can remember that 0 is 32, okay, you use that as your base, then you know that for every 5 the Celsius goes up, the Fahrenheit's going to go up 9. Or for every 5 the Celsius goes down, the Fahrenheit's going to go down by 9, okay? So 0 and 32, and then add 5 to 0, 5, 9 to 32, 41. So 5 is 41. Now add 5 more. 10, okay, 5 plus 5 is 10, and then 41 plus 9 is 50, okay? So you keep going, 15, 59, 20, 68, 25, 77, 30, 86, and so forth. And then you go down the same way. So being the nerd that I am, when I come across those bank thermometers that show both of them, I'll try to guess what the conversion is before it flips the display, so. Now you know why I didn't have a life for very, very long. Okay, so anyway, we got temperature Celsius, temperature Fahrenheit, and then the speed of sound in meters per second and the conversion to miles per hour. So at 32 degrees Fahrenheit, the speed of sound is 740.9 miles per hour, and at 40 degrees Celsius, which is 104 Fahrenheit, is 793.3. I'm going to take myself out of the picture here because I'm going to be blocking some of this text, okay? So the speed of sound is more than 50 miles an hour faster at a temperature of 104 as opposed to a temperature of 32. Okie dokie. The speed of light is so fast that to the human being at relatively short distances, it is almost instantaneous, okay? So you really don't have to worry too much about, how long it's going to take from a thunderstorm for lightning to get to your eye. Now, FYI, today the sun is 94,495,366 miles away from the Earth, and light travels at a speed of 670,615,288 miles per hour, thus taking 8.32 minutes to reach the Earth, okay? That would be true if we didn't have an atmosphere. And the atmosphere actually bends the sun's rays toward us before the sun is actually on a line with our sight. So we gain 2 minutes at the beginning of the day and 2 minutes at the end of the day due to the refraction of the sunlight by the Earth's atmosphere. So actually it takes about 6.32 minutes to get to us at sunrise and 6.32 minutes to get to us at sunset. Okay, that's just sort of a sidelight there. So, at short distances, since light gets to us almost instantaneously, let us focus on the speed of sound. That's the thing that we really want to hone in on here. So, for those of you that are mathematically oriented, this is going to be boring, but I thought that some of you might be interested in knowing how we convert from one unit to another, okay? And this is something I first learned back in 7th grade, and it's called the factor label method. At least that's what my teacher called it back then. And so I'm just going to take you through this, and I think this will make a lot of sense. So let's start off at the speed of sound at 95 degrees Fahrenheit is 351.8 meters per second, okay? So we're starting off with that. Now, this is what's called a conversion factor, okay? We know that 1 meter is equal to 39.37 inches, okay? And so you arrange the units so that one is on top of the other and they cancel out. So the meters go bye-bye, and now we have inches per second, okay? Now, we know that 1 foot is equal to 12 inches. So we arrange the labels so that inches will cancel out. There they go. Now we've got feet per second. Now we know that 1 mile is 5,280 feet, and the feet are on top of each other here, actually foot and feet, and so they cancel out. And so now you've got miles per second. And it turns out that sound goes 0.2186 miles every second. So if we're interested in finding out how many or how long it takes to go 1 mile, okay, then you simply invert that fraction that you saw there, 0.2186 over 1, put it 1 over 0.2186 so the miles cancel, okay? And what you end up with is 4.57 seconds, okay? So that means that at 95 degrees Fahrenheit, as soon as you see the lightning, it is going to take the sound 4.57 seconds to get to your ear, okay? Because the lightning is heating up the air so quickly that there's a rapid expansion of that air. That's what creates the sound of thunder. And so for every mile you are away from that, it's going to take 4.57 seconds to get to your ear. Okay, the range in seconds from 32 degrees Fahrenheit to 104 degrees Fahrenheit is 0.32 seconds. So don't sweat the small stuff, okay? In other words, don't worry so much about, oh my gosh, is my calculation going to be way off if it's 40 degrees as opposed to 80 degrees? It's not going to make that much of a difference, okay? So the rule is that as soon as you see the lightning and 4.5 or almost, 4.5 seconds goes by, then for every 4.5 seconds you're able to count, the lightning is 1 mile away. If it's 9 seconds or thereabouts, then it's 2 miles away, and so forth. So it's not a second per mile, okay? It's 4.57 seconds per mile. All right. I hope you found that interesting. Those are the credits, and that is the bonus weather video for today. I'll put myself back in here. And the next bonus video will be coming up on Monday, and the next daily weather update will be coming up later this afternoon. I sort of like this thing of doing the bonus in the morning because then that breaks things up a little bit, and there's not as much to do later in the afternoon and early evening. So I hope you find this useful, and I'm probably going to keep doing it this way. So, all right, folks, you all take care, and we will talk to you again later today. Take care, everybody.